This learning session. So what we're going to be focusing on today is, if I can find my mouse, here it is, something called infrastructure as a service. So up until this point, we've been using kind of like serverless compute, which is stuff like Lambda and Dynamo. Those live on platform as a service. You can run an application and you can store some data. Infrastructure as a service, you have more basic control to the underlying system, what's going on. This diagram is really good for kind of explaining the differences. Because it's how Amazon works and all the other major cloud players, is that you're actually running a virtual machine when you're running an operating system. So you don't have access to like the bare metal of what's going on. But you do have control of like the operating system, the runtime, all other kind of components of what you're working with. And so in this, we'll kind of go into the first little foray into networking a little bit. Networking can be extremely complex with these systems, but we're just going to play around with some kind of simple things. Boom. So what we're going to be using right now is EC2. EC2 is arguably the backbone of AWS. Most of like their own services are made to either run on top of EC2 or to actually run inside of EC2 without like showing those details. So, and you can follow along to boom. Go to instances right here, and I'll make this a bit bigger. Right now I have two running, just setting up to play with, but we're going to launch our own. Alright, so we will launch an instance. Now, with all these services, you want to keep an eye on pricing. We're going to keep everything in free tier, but we can explore a little bit, and then you can select show me only free tier. You still have a lot of options. You have their own Linux. The Amazon ones are optimized for their systems. Red Hat, Ubuntu. You can even run Windows and .NET if you want. So if we look at AWS EC2 pricing, we can look at the free tier. You get 750 hours per month for the first year. So after you make your account for, again, those first 12 months, each month you can have up to 750 hours before you have to pay for anything at all. You do pay after you go beyond that, or if you go with different images that aren't in free tier, then you do have to pay. What we're looking at right now are something called on-demand images. So there are three major types of images that you can use. One, on demand, is you pay as you use it. I think they're at per minute or per second billing on them. It used to be you had to pay for the full hour. So if you only need to run it for 10 minutes, you might as well keep it for another 48, 49 before you shut it off. But now they do it per minute, maybe even per second. I'll have to look into that. But so as soon as you're done with it, you can just turn it off and you'll stop being charged for it. The other options, one is called reserved, and that's you basically say, I want to buy an instance to use for a year or 3 years or 5 years or whatever period of time. And you get a discount for paying for it somewhat in advance. The third one, which is also a very popular thing to do, is something called a spot fleet. So reserved instances are the top. You have those that are guaranteed. Right below them are on demand. You pay as you use them. But even with reserved and on demand, they don't use all their compute. They don't use all the possible virtual machines they could use. So what they do is they have something called spot. You basically bid to get some compute. The downside is with spot, you don't have anything guaranteed. They'll give you, it's either 1 to 5 minutes where it's saying, hey, someone has either outbid you or someone wants an on-demand or reserved instance. So we're going to kick you off of this one. And you could still get other ones. so there's a higher rate of churn, but you get a much lower price if you use the spot fleet. We're just going to look at on-demand right now, because on-demand is within free tier, and what we're doing is all within free tier. So let's just pick this one, top one. Again, they show you which one is free tier eligible, right here. All right. So you can specify, of course, how many virtual machines you want. This is how you can set up spot. Here is the current price that people are kind of bidding. If you want a machine, you have to outbid them. So it then becomes that sort of competition. So if someone outbids you, they take your machine. And then you can set up to happen at specific times. If you lose it, you get it like you apply for another one. You can make this more complex too. Network, we'll go into networking later. They give you default VPC, which is a virtual private cloud. We'll use that for now. And we'll use this for now too, default subnet. Use this too, keep this as is for this one. This is saying it's going to be open and accessible to the internet. Yep, and we don't need to change any of these right now. And one thing that we might get to later is something called an auto-scaling group. If you want for, let's say you have an application that's going to be running, and you need a couple servers to be kind of managing at all times, you can make an auto-scaling group that whenever an alarm is triggered, an alarm can be triggered, for example, if all your machines are using up too much CPU, for example. Then an alarm will be triggered, and it will actually make another instance of the type you specify. And then you can have it redistribute the load to balance it out. That way, when you have a lot of people visiting, let's say, your website, if it's hosted via a server, then you can actually make replicas of your website when a whole bunch of people come there. And then when people aren't there, you can have an alarm for when CPU is below a threshold. Then you can actually take them away. And with an auto-scaling group, they'll manage a lot of that for you. So it's a lot easier to work with. We won't go into any of this right now. We're just going to get the thing up there. Yeah. Boom. At storage, you can keep it default. Boom. Not going to do any tags for this. And I'll do this one. If you say create a new one, it will probably say like launch wizard 1 and all of this. I'll just use launch wizard 2, which has the same configuration. So what this is saying is anyone can SSH with me. Anyone right here. So this is a whole wide internet. You can limit it how you want. But for now, we're going to leave it the whole wide internet can SSH with me through port 22. So the standard kind of SSH. You launch. It's saying it's a bit worried because it's saying, hey, you're open to the entire world. But that's how we want to be right now. So we will launch. And I'll actually do creating a new key pair. So this will be called what? All right, save it. All right, so now it's launching. And we can see it working. So right now it's starting up. You can see the status checks right now. They haven't come in yet. But these make sure that it's working. These two status checks, once it goes here, will verify that your instance is up and running. What we'll do here is actually, we will move whatever your key file that you set up. I'm actually just going to move it to my desktop, kind of like I have this one. Nice. So now it's running, but the status checks haven't come in yet. So it wouldn't be effective to connect to yet. If you see here, we have right now. And we can actually look what this looks like. It's just the private key. So just verifying the identity so that we can SSH into the machine. Now, because this is secret, you actually shouldn't show whatever your keys are, but because this is just for kind of this purpose, and everything's going to be deleted afterward, it's fine for me to kind of show what the key is. All right. Status checks tend to take a bit. So while this is happening, we're actually going to launch another instance as well. We do the same type. Most of the same details except for one thing. We're going to disable the auto sign-in IP. So what this is saying is that this instance that we're making cannot be accessed by the internet because it doesn't have a publicly facing IP address. And then everything else I'm going to make the exact same, including the SSHing on port 22 from anywhere. And I'll actually use Human Cloud again. So if we look at this right here, if we click on it, actions, there we go. If we click on this one right here, actions connect. So it's telling you how to connect to this instance. This is really helpful because, for example, for the Ubuntu image, the user right here is just called Ubuntu. So with whatever image you're using, this will give you a little guide on how to kind of SSH into it. So we're just going to follow it. We're going to 400. I'll go desktop. Okay. And there, so SSH. And right now, it's 2 out of 2 checked. It's all ready to go. So we should be able to connect to it now. And boom, we're in. We're in our machine. We can do whatever. Let's say if we had opened an HTTP port, we would be able to, for example, host a website out of here. Right now, we're not going to do anything interesting with it. We're just kind of setting it up. Boom. So now we have that one over. And what I'm actually going to do is I'm actually going to transfer a file to this machine. Transferring a file via SSH is pretty similar to SSHing into it. SSH, copy. Then the file I'm going to do is actually the UMN Cloud PEM. I'm going to transport it to home -EC2 user. Just and then boom. It's there. So now if we SSH into it, ooh, there's some updates available. Nice. There it is. Now I'll explore why I did this in a minute. Let's see if this is ready to go. Not quite. So while we're waiting on this, we'll explore some other things we can do kind of while we're here. This is where you can manage your spot. And later on, I'll probably end up doing a session on working with spot instances, mainly because they're so cheap. So they're good to kind of know how to use and how to work with. Reserved instances I won't go into. Again, you're saying I'm going to have this instance for a full year, let's say. So AMIs are the images. What you can do is I have some 2 example ones here. You can, once you get an image that you've run with and set up, you can install their libraries, install your custom code, whatever you want onto there. And let's say you have something ready to go that you want to work with. You can make it its own image so that later on you can just pull that in and run that with all that configuration and with all those libraries already in there. This right here, this is block store. This is the storage. Not sure with EBS, but they also have something called EFS, which also is for file storage. But what you can do is you can save things to the file storage, and then you can move the file storage between instances and even share storage. Not sure about EBS, so I'm pretty sure you can do that with EFS. And then, let's look here. So one concern when you have just a public IP, which is what this instance has. This instance just has the public IP, which one is it? 3.93.153.130. That's just its public IP. But anytime you spin up a new machine, even if it's the same type, it'll just have a randomly assigned IP. One thing you can do is you can say, I want an elastic IP. I want an IP address that doesn't change. And I can give that IP address to whatever machine I want. That way, you always know what IP address you're connecting to, and the underlying machine can change. And then load balancing, which is kind of what we talked about earlier with the auto-scaling group, which they go into here, but scale up an instance, distribute the load. Yeah, you can explore some stuff later. But now that the instances are all up, what we'll do is we will SSH into, let's see, this one right here. This is the one we just made. So we will, boom, 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 connect to it. So we already did this. So let's, all right, so let's SSH into that machine. Why do you guys think this isn't working? Do you guys have any thoughts on why we were able to SSH into this machine fine? We're able to SSH into this machine fine, but not this machine.
It's private.
Yep, exactly. Because this one doesn't have a publicly available IP and domain name, we physically cannot access it from the outside internet. And we can let this run until, it says it timed out trying. But what we can do is we can connect to it from our other instance. Because what Amazon does is it may not be accessible to the outside internet because it doesn't have a public IP address, but it does have its own internal private IP address. So any of the instances that are within this same VPC, they can all talk to each other. So this is one way you can make sure your applications are more secure. A good example usage of this, which can often use subnets too. You can say subnet, which is basically a component of the VPC. This one's private, this one's public. Anything in here is public, anything in here is private. So in the private one, you can put your database, for example. You don't want just anyone being able to access your database or try and either flood it with requests to log in, or just try and find the password by attempting to log in a bunch of times into your database. So something you can do is you can say, okay, the database is right here in the private one, but I'll have a server right here in the public one that will transfer requests through the public server to the database. And it'll make sure that the requests are clean, can format them, kind of do whatever you want to protect what's in the private area. Nice. So now we are in here. So exit. Okay, let's see. So as you saw, when we were in the other machine, the first machine, we were able to ping, I use Google as an example, but we were able to ping it just fine. When I SSH back into the private machine, it can't. The private machine, by default, doesn't have internet. It doesn't have a public IP address. Not only can nothing reach it from the outside internet, it cannot touch the outside internet. There are ways you can actually go around this. There's something called a NAT gateway, which we won't explore too much. Network interfaces. Yeah. Nice. So a NAT gateway works similar to having all the requests go from one instance that's publicly accessible, basically through it to the other instance. And then back out through, kind of like proxying through a publicly available one. And whatever connecting from the outside world doesn't know they're interacting with the private thing. They only think they're interacting with the public one. But nice. All right. Now that we've done that, exit. All right. Let's SSH here. So now that we've done this, it's a very crucial next step, especially if we're playing around with this on your own, and that is to delete everything. Boom, actions, instance state. So you don't just want to stop it. You actually want to fully terminate the thing. So I'll actually go down here and we will terminate. Now with terminating the instance here, it will also get rid of, for example, its storage right here. As this gets deleted, the storage by default also gets deleted. You can change it so that when you delete instance, it doesn't delete the storage, kind of like I was talking about having like a consistent file system that's shared across multiple machines, or by like new machines coming into the system. But by default, these will go away, which is what we want in this case. I'll actually delete my snapshot here. I'll have to wait for it to be deleted. That's fine. All right, nice. So that's a little bit about EC2. Let's see. I'll look at the key pairs. There's two right here that they'll use. So that went a little faster than I expected. So we're just going to play around with auto scaling for a little bit. And again, if anyone has any questions, just let me know. But we're going to see what their kind of basic auto scaling group is. So we'll use the same image, pretty similar configurations, test launch, cloud, launch, all right, nice. Everything's just open on port 22. kind of similar. Use human cloud. Group, do one instance, that VPC. We won't specify the subnet, we'll let it just choose randomly. I guess we have to pick one. Alright, we'll go here. We'll just make them available on all the subnets. So keep this group at its initial size. Alright, so this will be very, okay. We won't do any notifications, no tags, review. Check grace period 300 seconds. So we'll give it, let's say 5 minutes grace period after failing a health check before it spins up another one, it looks like. We'll create an auto-scaling group. So I want you to be very careful when creating an auto-scaling group, because right here, it'll be desired min max 1. So it won't scale beyond 1. And boom, if you look at instances. So this will actually provision and always make sure that there's at least one instance of, and here it is, of the same type. And we can see these all got terminated in usually around a half hour to an hour. They won't even show up on the console anymore. But, so this is spinning up, and we can of course do more complicated things. We could have made the policy such that it could actually go beyond 1 based on different, something called CloudWatch alarms, which you can actually look into. So CloudWatch is a way to monitor your resources and actually kick off different events because of them. So we could create an alarm, select a metric, say it's for EC2. See. So it could be for this instance, the network output. Whether it exceeds some certain value, select metric, name description. If it's greater than something for a certain amount of time, then action is a big thing. Yep, and then boom, we can actually just make it do auto scaling. So this is what kind of I'm talking about when I mean by scaling based on utilization, based on the resources. Now, if doing it through the auto scaling group when you make it is more effective, but we're not going to set that up right now. All right. And then this is the dangerous thing about setting up an auto scaling group, especially for something that you're going to play with, is let's say I terminate this instance. I decided I was done playing with everything that I was working with, and I'll just turn this off. Because of the nature of the auto-scaling group, the ASG, look at this. It will realize that it doesn't have any more instances associated with it anymore, and it will spin up another one. So even if you delete this and then you walk away, you'll still have an instance going. So before you even delete your instance, let's see if it doesn't have another one up yet. Let's see if we can beat it. Before you even delete your instance, it's better to delete your auto-scaling group. All right, next. So by doing this, we've actually detached the instance from the auto-scaling group, which is fine because we're deleting the instance. and boom, everything's gone. So this is kind of how you can set up different machines to kind of run things on. I'm not going to get into it, but another service they have that's built directly on top of EC2, something called ECS. What this will do is it will also, underlying it is EC2. Everything's running on EC2 instances. But what you actually run are Docker containers. Who here kind of has experience using Docker? No one? Nice. We will do a Docker session. Docker is great. I use it here. Boom, boom, boom. Here's my little Docker daemon running right now. I use Docker both like with cloud stuff and on my local machine. If you look at the website, we did a session last year on Docker, but we'll definitely do something with Docker this year too. Maybe with Docker and Kubernetes. We'll do that later. All right, so that's the basics with EC2. Does anyone have any kind of questions right now? We didn't look at anything with routing or anything with networking yet, or at the subnets or VPCs themselves. We're going to kind of leave that to be their own thing. It can be kind of hairy. But yeah, here, I'll turn this off.